All right, welcome back, nerds. Today we have what? The 13th of February, which means tomorrow is the 14th of February. Which, if you are looking to buy in the commercialization of love, you should really lean into it and make lots of money for people to show your love. All right, cool. This problem, we'll jump in right here. This is where I left you guys off. I have no idea what to do. Help. Okay, so I heard take the 2, and that's where the last thing that I heard. How we think about this little part right here is going to vary depending on who you are. When I look at this, I don't mind keeping it here right now, but I totally understand if you'd rather change it to a root. How many of you guys would be more comfortable with this if it were a root, like a radical instead? And that's fair. Like, it's reasonable. We'll see that there's a shortcut around it if we don't have it. Lando. To 3 1/4. So let's check out what happens. Let's make the jump to radical to see if it's any more clear. Am I doing radical in the numerator as well? Okay. And I can, like, it doesn't matter to me. We'll work this way. If I change the numerator to a radical, which of these terms up here are underneath the radical? Is it 3 and x and y, or is it just x and y? Is it just x? Is it just y? Why? So it is a fourth root. I agree with you. Is 3 inside of this fourth root, though? Is it part of the radicand? Why not? And how can you tell it's not? Seabass, go ahead. Love that. I agree with you. Another way to think about it, and it relates to that parenthesis idea, Sebastian, is these exponents are only connected to whatever they're connected to, right? If we had parentheses here, it means something very different. So when we rewrite this little piece, and I'm going to get rid of those, we have 3, and as Michael had said, it's the fourth root, and I agree with that. My marker is a little bit too bold up here. 3 and the fourth root of what's in here in the numerator? X to what power? To the 3, and we're just using, this is the power, this is the root, and I could do it the fourth root of x cubed times the fourth root of y cubed, whatever, they both fourth roots. So let's just shove them together then, because I know that they can split up anyway. So there's y to the 1 if you want to write it. Downstairs, is there a better way to write this? So I know it's going to be a fourth root of something. And here's my challenge for you. I want you guys, as a little warm-up, as a reminder, and I'm stealing this from Miss Sweet because I love this idea. I'm going to give you guys like 90 seconds. Off on the side, even if you've done this problem, I want you to write this thing, 2 to the 5/4, a few different ways. See if there's a best way that we could possibly think about it to make this convenient for us. 90 seconds, and just as an example, you could do, this would be a weird one to do, but you could do 2 times 2 times 2 times 2 times 2 to the 1/4. There's a way to rewrite it. I want a few of them, and I want to see if we can figure out what's the best one naturally. 90 seconds, talk with your neighbors. Just for the record, there is a best way to think about this if we keep it in this form, but there's not a one right way, is a cool thing. So somebody give me another way to write this. I hope we get a bunch of them. And Michael, I'm going to save yours for last. Anybody have another way to write this? Is it Michael's? Okay, so I'm just going to look real quick. Could I write this, and this would be a weird way to do it, instead of 2 times 2 times 2 times 2, we already know it could be 2 to the 5th. Could I write this, if I wanted, as 2 squared times 2 cubed? Does it still work? Because these exponents do what? Okay, so that still works. Is that the way that I should write it? No. Give me another way I could do it. So I could do 4, so I could do 4 times 2 if I wanted. I'm not going to bail on my 2's yet, and there's a reason that I'm not going to. But you are absolutely correct. Ooh, louder, Angel. 2 to the 4th times 2. Now, if I just do this, there's really a what power here? 1. I'm going to make the claim that this is the best way that we can possibly think about it. Why? Holy fourth root. Okay, well, let's try that. If I write this instead and I get 2 to the 4th times 2, I now have a really convenient way to simplify this all the way down. Right now, I have a radical in the denominator, right? Is that allowed? So we're going to have to sneak in some not brand new ideas, but we're taking care of this first. And maybe there's other ways that we can do this, but we'll get here. Hey, I was told these were singing deliveries. Hold on, I got you. I got you. I can get music if that's all you need. You realize we're not on Twitter. Whatever. He just asked to chat, not ironically. Do people do that non-ironically? Hey, no dapping. All right. I didn't get one. I just want to point that out. All right. So check it out. Here we are. Now, as we deal with this, why was this the best option? The numerator doesn't have to change. It's 3 times the 4th root of this mess. What's the denominator change to? What was the point of writing it like this? So I'm going to make you fix the language. We don't have a square root anywhere. Did you not say square root? There we go. What's the 4th root of this 2 to the 4? A 2, and what stayed inside? A 2. Now, if you got here, I'm feeling pretty good. And this is not the only way to do the problem, but we're just working with all the radicals first. Am I done? It would be the 4th root. I have a typo. Thank you. Good catch, Seabass. And we're done. Oh my gosh. I also thought there was still a radical in the denominator. And if we look at the stuff that we wrote yesterday, what's one of the things we're not allowed to have? A radical in the denominator. Now, this is, again, I want to stress, not the only way. And we're going to keep building up this idea. How do I get rid of this? You could just leave it. I'm not going to, but maybe you could. So I like what you're thinking here, but if I just divide these, it doesn't divide itself out. Now, here's the crazy thing that we're going to add. Right now, we have gone through all the radical stuff, right? Like we knocked it all out. And some of us may do this a different way. But we're about to sneak in a vocab in here in this problem that I think you guys have seen. Do you guys know what an irrational number is? And I guess, do you recall? What is an irrational number? So I wouldn't typically think of irrationals necessarily as just being negative. What are the rationals numbers? Ratio means we can write that number as a what? A fraction. Are there any, or a ratio, I'm cool with that. Are there any numbers that we can't write as a fraction? Pi is a good example of it, right? Because you can't write it. You can approximate it with a fraction, but it never stops. Are there any other numbers that do that? So if it repeats, it doesn't count as irrational. Because 1/3 does repeat. That's 0.33333. It's still rational. So we need a decimal that never repeats and never ends. What am I trying to take the 4th root of? Is 2 a perfect 4th power number? So, and that's a weird one to say because I don't have a good way to do it. Like, are there numbers that we can take nice square roots of? Yeah. Are there numbers that we cannot take nice square roots of? Yeah. If you have a root and it's not a nice one, so it's not a cube or it's not a 4th power like we have right here, we have a decimal that will never repeat, will never stop. We have an irrational number. Every square root of a not square number is irrational. And there's way more than just pi. That's just the one that you guys have worked with the most. So as we're dealing with this, if I want to change this, and I know I have an equal sign, but am I really messing with two sides of an equation right now? And maybe this would be a better thing to put instead of equal, just so we don't mislead it. Do I have two sides to multiply something by? Or am I only messing with just this side? Like, I'm not touching anything else, right? There's no x equals or something over here that we're solving for. So if I don't want to mess with both sides of an equation because we don't have that, what's my other option if I want to change the way stuff looks? Like, and you guys are you'll know it as soon as I have it. 5 times something, I don't want to change it. What could I multiply this by? It could be 5 over 5. It could be 15 over 15. It could be 157 over 157. I'm choosing a bunch of clever choices of 1. Now, if I wanted this radical to be completely gone, right now, what's the power on this 2? It's a 1. But if I wanted to be able to take the 4th root of what's left in here, I'd have to get rid of it. Do you guys agree? So there's 2 ways we can think about this. We're just going to check. Thumbs up says I'm more comfortable with the radical notation with the square or fourth root written, or thumbs down if I'm more comfortable with the exponents. Thumbs up if you like the radical stuff with this symbol. This symbol is radical stuff. So thumbs up if you prefer to do it like this. Thumbs down if you'd prefer to do it like this. That is so cool. We are like straight up 50%, pretty close to that, which is wild. Okay, we can look at it with both versions. This one, because we've elected to write it in the radicals, I'm going to stick with it for now, but we'll do another one together if we have to. Okay, what do I need this exponent to become if I want it to be able to take a fourth root of it? I don't need 2 to the 1. I need 2 to the 4. Now, to be able to make this work, we are going to do a fancy process. I'm going to choose a choice of 1. And I'm writing it way bigger than I need to right now, but I'm doing this so I can put a big star. We are, and you use this language in geometry, I'm certain of it, but you may not remember it. We are right now about to do what's called rationalize. And I'm going to say rationalizing because we're like actually doing this right now. We are trying to make which part of this fraction a rational number. I don't want the fourth root of 2 because it's irrational. Is this the numerator or denominator that we're trying to fix? Denominator. We are rationalizing the denominator is what we're doing right now. Now, that language, just yes or no, and we'll just do like out loud. Do you guys recall it? Ever talking about rationalizing the denominator? Okay. How well do you remember geometry from last year? So didn't ask if you liked it or hated it, just for the record. Bummer that you hated it. Geometry's pretty chill. I don't know. I'm going to show you guys something, and just in case, you don't have to write it down, but I think I can show you exactly where in geometry you guys did this last year. So in pink, this is just review stuff, but don't zone out because we use these ideas constantly. Do you ever remember working with triangles in geometry? You all right? I don't know who. I think it was you. I'm not sure. Okay. Everybody remember working with triangles? I sure hope so. What kind of triangle did you hope you get to work with like 90% of the time? Isosceles are really nice, or right triangles. So let's say that this is a right triangle. Now, you don't have to have this. It's good review if you don't remember it, because we will be doing some triangle stuff here in the coming chapters. For real, what's the nicest, or a couple of the nice right triangles? Because there's a bunch of them, right? Like, there's 2 nicest ones. 2 nicest right triangles that you guys dealt with a lot in geometry. I'll give you one of them. 45, 45, 90 is a really nice right triangle because it's an isosceles right triangle, and there's some really awesome stuff that works out. 60, 60, 60 is really nice. That's equilateral, but we can't make a 60, 60, 60 triangle into a right triangle because they're all 60. But there's one more right triangle that exists. 45, 45, 90s were really nice. There's one more. 30, 60, 90. Do you guys remember talking about 30, 60, 90 triangles last year? Okay, you should. You did a little bit of sine, cosine, tangent stuff in geometry, correct? Okay, so do you remember anything about this triangle? If this length, and we're just going to see how well you remember it. If this is 4, do you know how to get to the other leg? Like, here's my short leg, here's the hypotenuse, and here's the long leg. Okay, Pythagorean theorem works so well if you know how many sides. But how many sides did I give you? Ah, shucks, Pythagorean theorem is out. So sine, cosine, tangent stuff does play a role here. We're not going to do sine, cosine, tangent, just so you know. Ooh, say it again? Nope, it's not 60 degrees equal to 4. Okay, so I don't know the language that Miss Osmond used, just to be honest. When I teach this, I call this the queen, the king. The very most important leg of the entire triangle is this short side. And the reason, and if we don't remember how to move between these here, I'm going to change where that 4 is right now. If this were the 4 instead, everything is easy. Now, you may not remember this, and hopefully you remember seeing it. On a 30, 60, 90, and this is a special triangle, to go from the short leg to the hypotenuse, you double it. To go from the short leg to this side, does anybody remember what we multiply by? So it's not root 5. You're close. How many angles are different here? And it's a weird question, but they are all three different, right? So we need the 4 times the square root of how many angles were different again? And here it is. If you had root 2 in your head, you're good. You're just thinking about doing root 2 with 45, 90s. Now, right there, we're just multiplying. But if I said that this was 4, if I know that to go this direction, we had to multiply by root 3 to get it, which is what you guys did last year, what do I do if I go the other direction? You don't cube it. Instead of multiplying by root 3, you divide by root 3. And this is exactly where you guys would have done this. You were not allowed to keep this answer last year for the length of a triangle because you're not allowed to keep radicals in the denominator. Anybody remember how we fix it? And that's okay, but what's really cool about this is we're in the exact same situation with this problem as we are here. This is a 3 to the 1, and we need it to be the square root, right? Ooh, I can't multiply by just root 3. That's not... Love it. Do you guys remember doing this? If you do, awesome. If you don't, less awesome. But we're going to do this. And if you weren't comfortable with it last year, we'll get another shot at it now. So this fixes this problem. And I'm going to finish this pink one just because it's going to bug me if I don't. What would the numerator give me? 4 root 3. And downstairs, it'd be root 3 times root 3, which is the square root of not 3, not 1. How do we multiply radicals? Do we have a property anywhere where we said what happens with this? I think we wrote this, and I'm waiting until I hear the pages turning, because I'm pretty sure we wrote this the other day. If I'm confusing with the other class, I'm terribly sorry, but I'm pretty sure we have this. We did write something like this. I'm almost confident of it. Did we really not? Oofda. All right. Well, we're going to sneak this in here. For this, I'm going to show you guys that even if we didn't explicitly write it, I think we have. Is there another way we could write this? AB to what power? Okay. So this is awesome because if we didn't write it, my bad. But maybe we kind of did, just not explicitly. How does this rule work? A to the 1/2 and B to the 1/2? Like, that's the property we saw yesterday, right? How would I make that look radical? How would I write A to the 1/2? Root A, and I'd be multiplying it by, how do I write B to the 1/2? We can multiply radicals together and combine them into a single radicand. Okay, if we didn't write this exact property with the square roots, my bad. But if we did the exponent properties, I think it's reasonable that you guys can accept that this is in fact true. We just showed it. Okay, so looking at this, if I need this to become the 4th root of 2 to the 4th, if I want to multiply them, I need the same index. So I need to choose a clever choice of 1 here. And I stopped this problem for some reason, but we'll come back to it. What do I need to multiply this by to get it to be 2 to the 4th inside? 2 to the 1 times what will get me to 2 to the 4? So 2 to the 1 times 2 to the question mark is going to give me 2 to the 4, because I want a nice 4th root here. And as soon as we write it there, you said what? If I do 2 to the 3rd, will this work out for me? Yeah, I think so. So I'm going to multiply each part, a clever choice of 1 here. I'm doing the 4th root to make sure they match, 2 to the 3rd. And upstairs, what do I need to multiply by then? The 4th root of 2 to the 3rd. Now, looking at this, let's just deal with the numerator first. I don't know the 4th root of 2 cubed, right? Like, it just doesn't work. Can I combine both of these, this one and this one, into a single radical then, using these properties here? Am I allowed to just shove them together if they're multiplying? Yeah, for sure. So what's in my numerator? It's 3 times the 4th root of what? So I like the x cubed and the y, but I don't like just 2. 2 to the 3rd. Do you want me to write 2 to the 3rd, or should I just change it to 8? Either way, it's the same thing. 8 is my 2 cubed. I'm going to write 2 cubed on this step. If you want to write 8 here, I'm good with it. Okay, denominator. This is the ugliest part, but we've already done the hard work here. I still have a 2 out front, and now I get the fourth root of, I have 2 to the 1 times 2 to the 3. It's 2 to the 4th. What is the awesome, convenient thing that just happened? What's the fourth root of this? 2. So one more line here, and now I'll change this. 8x cubed y. And in the denominator, I had a 2 times, and what's the fourth root of 2 to the 4th again? 2 times 2. And I'm only writing so many lines to make sure every little step shows in case you're struggling with it. And luckily for me, I do this on a computer, and I can just do this. Almost consistent. What do we say the denominator is going to change to? Do we have any radicals in the denominator? Any of the same variable on the top and bottom? Are there any fractions anywhere that we can simplify? Any radicals that we can simplify further? So what do we do? Yeah, we box it or say, hey, check it out. Here's my wonderful answer. Now, these things, they take practice. This was a significantly harder problem than the other ones that we did, I think. So you're asking why the 2 cubed here? I don't know why I changed it back to 2 cubed. Because in my head I had it. Oh, because I copied it is all that I did. I would keep this 8. Good eye. Should we do another one? Okay, this one I want you guys to do again or with your neighbors. We're going to make this a little bit easier. I'm going to zoom out just to see where we're at here. And let's check it. So I just want to stay consistent. So we are writing our reduced radical form, and we'll do one more like this. Easier or harder than that one? I heard somebody say harder. I appreciate that. If you legitimately do want a harder one, I'm not going to make everybody do a harder one than that. But if you're like killing this and you're doing really well and you're just going to be bored for the next 3 minutes while people work through this, let me know. I'll give you a harder one. I'm good with it. But let's try B. This time, and how ugly do we want to make it? You guys said super duper ugly. So let's check it. We're in chapter 5, right? Bless you. All right. One more here. After this, I'm done with that, Kennedy. After this one, I'm cool with it. Okay, here we go. I want you guys to simplify for me the square root of 32x cubed over the square root of 16y. All you're doing is you are simplifying this down into that reduced radical form as much as possible. If this one is not engaging enough for you, please let me know. Or if you finish this one, I can give you another one, not as punishment, but I just don't want you to sit here bored. Cool. I'm going to give you guys 90 seconds. Chat it out with your neighbors. I want to see what you come up with. Trabaja. In a perfect world, we would all just agree automatically and we would all have the exact same thoughts, but then all of a sudden that world would not be perfect and be boring. Okay, so radical or exponent notation? Radical? Okay. So if we're doing radical, first thing, how can I rewrite this top part? So it's a square root of, is there a better way that I can write 32? I could write 2 to the 5th immediately. Now, if I'm taking a square root, I don't know that that really helps a ton. In my head, we could write it 2 to the 5th, and I'm good with that. Are there other ways that we could break it down? You could do 2 squared times 2 squared times 2 squared. Which root are we taking? Up top. This is the cube root, the 5th root, the 9th root, the square root. So here's where I want to start pivoting. We could break it all the way down to break it and get 2 to the 5th. Certainly. But here's my question for you. Do you know any squares? At least a few of them. Like 1 is a square because it's 1 by 1. 4 is a square because it's 2 by 2. 9, 16, 25, 36. Those are all my squares. Do you know some of them? Is there a way to break down 32 such that I have a square number as one of the factors? Oh. If I want to, can I take this route instead? Is that still 32? Now, the other way to do this would be 4 squared times 2. You could write 2 to the 5th. We're going to all get the same answer. This is how I would think about this problem, though. X cubed, is there a better way that I can write that if I'm taking the square root of it? X squared times X. Okay, deal. Now, I want you to make sure your radical symbol covers everything, because if I write it like this, do you guys agree that maybe there's a place to make a mistake later down the road if that's how I write it? What's different? Lando, if you're doing it just to be annoying to somebody, don't. What's wrong with this? Why don't I like what I changed with the symbol? Is there a different? So if you didn't see what I did, I'll put it here. Before I had this, and I had that red part on it, and then I erased it. Do those right now and this mean the exact same thing? What's different? Good. We need to make sure our notation doesn't leave us like a place to make mistakes. Make sure that whatever's your radicand, what we're taking the square root of, comes out. Now, down here, what would you do? Anybody know the square root of 16 or y? Oh, it's 4. And we get a root y left inside? Okay, at this point, there's a ton of simplification that's going to happen. Now, I want to clean up the numerator, and again, you probably do bigger steps than I do. And if you're really comfortable with it, you definitely do. If you're not very comfortable with it, you might not, and that's okay. What comes out of the numerator part? Anything that we know the square root of? A 4 from where? So square root of 16 is a 4. You got it. Anything else? Square root of x squared is x. What stayed inside? A 2 and an x. Okay, deal. Now, downstairs, I'm not going to change anything. We're just making it look a bit nicer right now. Are we done yet? Why not? Gosh, there's a radical. If I wanted to get rid of the radical in the denominator, I can't just have the square root of y. I need the square root of what? Y squared. What do I multiply root y by to make it so it becomes the square root of y squared? A clever choice of 1. What is that choice of 1 this time? Root y over root y. We're just going to pick whatever it is by itself or over itself. And by whatever it is, I mean the radical of the denominator, just to be super clear. All right, so here we go, root y over root y. And we are so close to being done. Before I multiply everything, is there anything that you guys notice in this one that might divide out? I have a 4 times x times square root of 2x and a 4 times root y. They divide out. They're gone. Easy. Okay, one more step. The numerator. If I have a radical times a radical, how do I deal with that? One more time. Right, as a single radical. Yeah, so this is up top the square root of what? 2xy. Love it. Now, the bottom part, I would like to do it in one line if that's okay. If I do root y times root y, this becomes the square root of y squared, which is? Okay, we are simplified at this point, mostly. Now, there's one more little wonky thing that we could do, but right now, do I have any same variables outside or as independent factors? Yo, did I make a mistake? Did I? Oh, I did. Thank you. This one is what you're talking about. My bad. Thank you. Okay. At this point, if we don't have anything else that we can clean up, there's no radicals in the denominator. I do see the same variable here, but if we keep trying to get rid of this y, stuff is going to fall apart because we might switch it to exponents and we wind up with a negative again and all of a sudden stuff is broken. Now, these problems, they take practice for sure. Do we need to do one more like this, or are we at a point where we can practice it on the homework? One more. Okay. Last one. Okay. Let's check it out and see how gross we can get with it. Yes, that was a good point. Okay. You guys have 60 seconds to decide amongst yourselves what the best Olympic sport is. I did not specify the year.